making this bigger so that we can see it better. Okay, so this is your problem for today. No, I didn't mean to do that. You're witnessing my technical difficulties. Here we go. This is what I was wanting to do. Not that you guys really care to see my face, but for whatever reason, it feels nicer when it's there. Okay, so this is your problem for today. You'll notice that you've got all three shapes today. So you've got a cylinder, you've got a cone, and you've got a sphere. So if you have to go back to the video where I showed the relationship between the three, actually, I'll write those formulas here just to remind you. Okay, so the cylinder. The cylinder's volume is pi r squared h. You take the area of the circle and then multiply it times the height of the cylinder. And the cone is 1/3 of that. You do the same thing. Volume is pi r squared h. And then you divide by 3. So pi r squared h divide by 3 for the cone. And then for the sphere, we said that the volume was pi r squared h times 2/3. I'm going to do an erase here. Okay. 2/3 pi r squared h. And I noticed on your work that a lot of you guys were using that other formula. Let me pause for a second here and talk to you for a minute. If we were in the classroom and you guys were going to take the EOG, I would be pretty insistent on you doing this 2/3 one, because the EOG, they don't give you the formula, and it's easier to remember the one formula and how the three things are related, especially because that's part of what we're supposed to know is how they're related. But because we're not actually taking the EOG, you guys don't really even have to memorize this formula. I'm going to give you this other formula. It's 4/3 pi r cubed. Okay. All right. So we've got the three problems, and you've got your three formulas, three different kinds of vases. Let's read the problem. Show your work in an organized way on notebook paper. If you don't have notebook paper, you can use regular paper. I know some of you guys have been using graph paper to write on. That's fine too. Mother's Day is next Sunday, and you would like to buy your mom a new vase to keep fresh flowers in the house. Pause, time out. Do something nice. If you've got a mom in your life, please do something nice for her. Things are really stressful right now, especially for moms. See if you can figure out something fun to do for her. Whether it's just making her a card or offer to do a chore that you wouldn't normally do. Okay? Mother's Day. Mother's Day next Sunday. And so in this problem, you want to buy her a vase to keep fresh flowers in their house. And mom often forgets to water their flowers. And they need a vase that holds a lot of water. In a catalog, there are 3 vases available, and you want to purchase the one that holds the most water because mom forgets to water. The first is a cylinder with a diameter of 10 and a height of 40. The second is a cone with a diameter of 16 and a height of 45. And the third is a sphere with a diameter of 18. So you'll notice they're all different sizes. So you can't just compare, um, because it's a cylinder, it would hold the most. You can't compare them that way. You're going to have to actually find the volume of all 3 things. Notice that they're giving you the diameters and not the radiuses or the radii. Okay. And then that should probably be all that you guys need from me to be able to solve this problem. And you've got some questions here. Which vase should you purchase? Obviously, you want the one that holds the most water. How much more water does the largest vase hold than the smallest? So you're going to subtract to find out that. And suppose the diameter of each decreases by 2 centimeters, which vase would hold the most water then? All right, so then you're going to decrease each and then figure out which one would still hold the most water. It does make a difference. And for the vase company designs a new vase that's shaped like a cylinder on the bottom and a cone on the top. So it has 2 parts. And the catalog states that its width is 12 and its height is 42. What would the height of the cylinder part have to be in order for the total volume to be 1,224 times pi centimeters cubed? So this is your challenge problem. This is the challenge for you guys. And I have a feeling that you guys will be able to figure that out. So, like I said before, number 4 is a challenge. And if you are taking way too long on it, then stop. You don't have to do it. Okay. Um, I wish we were doing this in class. Okay. I'm going to give this to you guys as a document where you can type your answers, I think. But when you need to upload your work to where you've organized it. Okay, that's all for me today. See you soon.